Okay, let's look at imaginary numbers, and then we'll reduce some square roots and we'll sort of put it in context. So imaginary numbers are basically just a definition, and the way it works is that the square root of a negative 1 is called I. So what that means is that you can take out negatives when they're underneath square roots, and instead of writing the negative, you're just going to write an I. So let's say that I wanted to solve the quadratic here, x squared plus 3x plus 3. One way to do that would be to use the quadratic formula. So 3 squared would be 9, minus 4a is 1, and c is 3, all divided by 2. So if I do the math right, I should get a negative here. So let's see what we get the square root of. So this is 9 minus 12, so that's 12. So that's the square root of a negative 3. Okay? So you could say now that there are no solutions, which is somewhat true. There are no real solutions. But from now on, we're going to want to do this. We're going to write this as the square root of 3, and the negative, we're just going to pull it out. That's an I, and that's a 2. So now we're going to say that this quadratic has two imaginary answers, a negative 3 plus the square root of 3i divided by 2, and a negative 3 minus the square root of 3i divided by 2. We can do some more stuff with I. We don't just run into it with quadratics. So let's see what else we can do. So if the square root of 5, when you square it, if you get 5, then when you take the square root of a negative 1, and when you square it, you should get a negative 1. Because that's sort of the definition of square roots and squaring. They're inverse to each other. So here, when you square this square root, you're left with only what's underneath. So that's a negative 7. You're left only with what's underneath. So that's a negative 25. And that means that this I squared, and keep in mind that I is the square root of a negative 1. So when you square that, that's worth a negative 1 like we just saw a moment ago. Okay? So that means we can work with i's and I squareds and things like that. So let's see, what do we have? I squared is a negative 1. I cubed is I times I squared, so that becomes a negative I, because that's a negative 1. And I to the fourth is an I squared times an I squared. So if you have two negative 1s and you square them, you're back at a positive 1. So that gives us a pattern that looks a little bit like this. So that's a negative 1. Oh, sorry. I is just I squared is a negative 1, I cubed is a negative I, and I to the fourth is 1. And then this is one pattern that you could memorize. So this is a pattern that some people memorize, and that's I to the fourth. And then based on that, we can do other stuff. I don't really have that memorized. I just have one thing memorized, and I'll show you that here in a second. So I to the fifth, well, we could sort of do this, because we just figured out that I to the fourth was 1, so I to the fifth is I again. And that's what I meant with this pattern continues. So the next one here, if that's I, that should be a negative 1. And can I indeed get that? Well, this is how I would have done it. I would have said there are 3 I squareds in I to the sixth, because 3 times 2 is 6. And each one of these is worth a negative 1. So when you cube a negative 1, you get a negative 1. Other stuff, well, you can involve numbers. So if you do this, you just do 2 times 3, which is 6, times 4, that's 24. And then count how many i's we have. We have 1, 2, 3, 4. And we just saw that I to the fourth was 1. So that's just 24. On this one, make sure that you just sort of distribute that cubed first. So this is I squared times 5i, and 2 cubed is 8. And then that's an I cubed. Excuse me. And then work with your numbers. So 5 times 8 is 40. 2 plus 1 is 3, plus 3 is 6. And we just saw a moment ago that that was a negative 1, so we're just going to borrow from what we did a moment ago. Well, what if you just have like I and then some weird exponent, like 23, or whatever number you can really think of? So I do it this way. The only thing that I really have memorized is I squareds. So I'm going to split off an even number of i's. And then I'm going to ask myself, well, how many squares are in 22? Well, there are 11. And each one of those is worth a negative 1. and 11 to the negative, or negative 1 to the 11th power is still going to be a negative, so this is a negative I. That's how that works here. So how does that work here? So 5 times 3, and keep in mind that I have to do this first, so that's 8i cubed. So 5 times 3 is 15, times 8 is 120. I have 3 here, plus 4 is 7, plus 1 more is an I to the 8th. And then, so I do it this way. So that's an even number of negatives, so that's 120. Some people might do it this way. If you have that pattern of 4s in your, then you could do it this way. So how many I to the 4ths do you have? 2. So that still gives you a positive 1. Okay, so that's some things that we can do with imaginary numbers. Alright, so the next thing we need to work on a little bit then is reducing square roots. So reducing square roots means this, and I'm going to do the first one, do the long way. Sorry. So 20 can be broken down. And what I mean with that is this: 20 divided by 2 is 10, divided by 2 is 5. So I could write this as the square root of 20 is 2 times 2 times 5, which is the square root of 2 times 2 times the square root of 5, which is the square root of 4 times the square root of 5, which is the square root of 4 is 2. So 2 square root of 5. So what I'm telling you here is that the square root of 20 is the same as 2 times the square root of 5. This is like reducing fractions. We can do the same thing with square roots. Sometimes it can be done much faster than that. What you're looking for then is like the largest perfect square that you can think of that you can divide 180 by. So if you're good with numbers, you might see this from the top of your head. You might see that 36 times 5 is 180. Well, the square root of 36 is 6, so this should give me 6 square root of 5. Okay, I wouldn't waste a lot of time on trying to find it. If you can see it, that's great. But if not, you can just break down the number and just keep dividing out by prime numbers until you end up with something like this. Okay? And then you're looking for pairs. Now, what I mean with that is this. These two give me 1, 2 on the outside. The reason for that is right here. See how I needed 2 2's to get a square root of 4, which is 2. So I'm trying to skip this step. I don't want to write this underneath the square root and then go to the 2. I can tell you right here that these 2's will give me 1 2 on the outside. These 3's will give me 1 3 on the outside. Then what am I left with is the square root of 5, because that's the only thing that I didn't pair up. And then that still is 6 square root of 5. So how do you break down square roots? Well, prime factor the number. So this is sort of a typical math teacher problem. Okay, I gave you a large number. It's sort of annoying to see, so you have to just work the problem here. So dividing it by 2. So that's 1008. Divide that by 2. That's 504. Divide that by 2. That's 252. Divide that by 2. That's 126. Divide that by 2. That is 63. That's not divisible by 2, so let's try dividing by 3. That's 21. Divided by 3 is 7. So what do I have? Well, I have 1 2. 2 2's. And 1 3. So 2 times 2 is 4 times 3 is 12. So this is 12 square root of this 2 here I didn't use, and this 7 I didn't use. So 2 times 7 is 14. So that's 12 times the square root of 14. Sometimes you get lucky. You might actually see a large square root in there. I mean, 144 times 10 is 1,440. I know what this one is. The square root of 144 is 12. And then just to make sure, you can just check, well, 10 is 2 times 5. Both of these are prime. I can't take a pair up, so that's it. So whatever works is what you should use there. So here's some more example problems. Either you can see right away what's in there or not. So 108. Well, I'm not really sure. So I don't want to waste a lot of time on it. Divided by 2 is 27. Divided by 3 is 9. Divided by 3 is 3. So that's 2 times 3 is 6 square root of 3. So I guess there was a 36 in there. 3 square root of 5 times the square root of 10. Well, think of the square root of 10 as the square root of 5 times 2. So these 5's are going to pair up. So this is 3 times 5 is 15 square root of 2. Okay, the other way to do that would have been 3, and then the square root of 5 times the square root of 10 is the square root of 50. And you can see in 50 that there's a 25 in there, so that would be 3 times the square root of 25 times 2. The square root of 25 is 5, so 5 times 3 is 50. So it works either way. Well, what if you have a negative? Well, just take the negative out first. You already know that that's going to be I. Okay, in 54, we just sort of broke down 54 over here, but okay, we'll do it anyway. So 54 divided by 2 is 27, divided by 3 is 9, divided by 3 is 3. So there are 2 3's in there. So that's 3 square root of 6, and then don't forget to copy the I. So you can do the same thing on this one that I did up here. If you can see that 12 is 6 times 2, you can split it. But because I have 2 things here, in this case it might just be easier to do this. This is 3 times the square root of 72 minus 4 times the square root of 6 times 3 is 18. Well, 72 is 36 times 2. So the square root of 36 is 6, so 6 times 3 is 18 square root of 2 minus 18 is 9 times 2, and the square root of 9 is 3. So 3 times 4 is 12 square root of 2. Well, those are the same. So that's 6 square root of 2. Okay, because these square roots are identical, you can subtract the coefficients here. It's like doing 18x minus 12x. Well, how about here? Well, when you square this expression, don't forget that you're going to have to square the 4 rows. So this is 16, and the square root of 3 squared will just give you 3. So that would be 48. How about this one? Well, you can do it the long way. You can do 3 square root of 2 times 3 square root of 2, which is similar to what we just did there. So 3 square root of 2, 3 times 3 is 9 times 2, plus 3 times the square root of 2 times 3 is 6, minus 3, this 3 now, and then the square root of 3 times the square root of 2 is still the square root of 6, and then minus the square root of 3 times itself is going to be 3. Okay, the reason this one is a minus is because you're doing a negative square root of 3 times a positive. So negative times a positive is a negative. Then here in the middle you get a cancellation. So 9 times 2 is 18 minus 3 is 15. Okay, that would have been one way to do it. The other way would have been to recognize this as that's an A, and then that's a B. So this is A minus B times A plus B. That's a conjugate pair. So you get A squared minus B squared. Well, that would have been a little bit faster because I can just do 3 square root of 2 squared minus the square root of 3 squared. So this is 9 times 2 is 18, minus the square root of 3 squared is 3, and 18 minus 3 is 15. Okay, same answer obviously, but different ways of getting there. Okay, thank you. Have a great day.